All right, good morning and welcome to our first lecture for this course. Yesterday we spent some time to try and get everyone up to speed about how the course will be conducted, basic things we need to know, and how to access the videos on YouTube, live sessions in Discord, or a mix of both, whatever you need. So today we are starting our actual first lecture, which will still be an introduction. And any questions that you have on the material and the concepts for this lecture and everyone in the future, feel free to ask, interrupt me as we go. Whenever you have a question, feel free to ask. But I do ask that any administration questions about the format of the course or Discord or YouTube or things like that, let's leave that until the end, because we did spend yesterday and we had a whole week to figure all those things out. So I don't want to interrupt the main lecture with things like that. That said, today is very much still an introduction. We might not take the full 50 minutes. We'll see how it goes. But there's certainly time for you to ask questions as we go. Being an introduction, you might find it extremely simple and familiar. We're definitely not doing there are different levels of first calculus course. In a Math 100, engineers and things like that, those courses jump in with new material from the start. They have a lot more to do and they have to really be speedy and get to it quickly. And it's much more difficult and intimidating for that reason. We have the luxury of slowly easing into things, remembering key pre-calculus concepts that we need to take forward. The truth is, many pre-calculus things that you learned, we don't need as often. We don't need to remember all the time, but there are some important things that I'll highlight that we want to take with us and always keep in mind. Some things are more important than others. So when we look at the numbering system for the topics that I have, and all of this is of course on the website, we showed it yesterday. The topics are always the same, even though you might look at a different book than the ones we have, or you might ignore a book completely. This will be my numbering system for our topics, and we're going to do topic 1A, just a little easing into things, talking about variables and equations and the way I want to think about these things. There are many ways. I don't know when you did these things, how long ago, how much attention you paid, if you remember anything. So it clears my conscience just to start at the beginning. So let's do it. Before we actually begin, can I just get confirmation in the chat for Discord and YouTube that everyone can hear me and see me and everything is up and running as it should be? I'm always paranoid. I might be speaking to myself and have a technical issue that I'm not aware of and no one says anything. Everyone just sits there. Because you're not there in person, I can't tell that you are hearing and seeing me as you should. Perfect, thank you. Can I get someone in YouTube to just confirm that everything is good on that end as well? I mean, it might be that I'm not looking at the right chat here because no one is saying anything in YouTube. Let me just refresh that. Okay, I refreshed it. If someone in YouTube can just tell me, confirm that you're seeing and hearing me, That would be wonderful. Nothing yet, but Discord is working, so I'll continue. Okay. So we are doing topic 1A, very simple. Okay, perfect, thank you. Variables. Let me not name it like this. Let me call it Precalculus Basics, because it should be extremely basic. Now, if you feel that it's too basic and you're going to fall asleep, just have a pillow nearby, so in case you randomly fall asleep, your head doesn't hit the table. But this is not supposed to be challenging in any way. Though, if it is, we're doing it for that reason. If you need a refresher on anything that we're doing in the first couple of weeks, that's the time to be aware of that, because I'm not wasting your time with anything that we're not going to need or use. The key concept that I want to think about is I want to think about mathematics in the correct way. There are many ways to think about it, some more complicated than others, and there's no need to overcomplicate things. I want to think of math as a language. And once I do, the more I do, the simpler it becomes, because I have a sense for how complicated it sometimes is to learn another language. Math is no different. You're learning another language, and with that comes the same kind of struggles. It has its own way of saying something in that language, its own challenges. But it's not really different than learning Spanish or any other language. So in that language, we have certain components. So the first one is the concept of a variable. If you have, now this is introduced fairly early in your school career, but we tend to think about variables just as X or Y and not really think about what they actually mean. They can be many things. It's simply a symbol to representing a number or quantity. And for some reason, perhaps I don't know what that quantity is, but I still want to keep track of it in a calculation. I still want to keep track of it in what I'm saying. And then I'll use a symbol to temporarily represent that. Sometimes I do know what the number is, but I don't want to write it. A symbol is just an alternative to representing the same thing. Like you might have multiple names, you might have your formal name, you might have a nickname, both refer to you. Now, we get into the habit of usually using an X or a Y and so on. But it could be any symbol. It could be any symbol at all. So I kind of want to mix it up and make weird symbols sometimes so that I can be aware of what its meaning is. All right, so the next thing we have that is sort of the way to use this variable, this symbol, in this mathematical language is the idea of an equation. Let me put squigglies under it because that's what I did first. Now, I want to see an equation as a mathematical sentence. So just like you're saying some sentence in English, this language has sentences as well. And it has a grammar and a structure to it. which means I can translate a mathematical sentence to and from an English sentence, or whatever language you are speaking. If it's a language, I should be able to translate to and from it. So if I have a mathematical sentence like 2x plus 1 equals, let's say, 15, then that can come from an English paragraph or sentence or couple of sentences, an English explanation. For example, we could have the English version of this. How should I start it? Let's make it more interesting. I'm thinking of a number, and it's unknown at this stage. I'm just going to do it in a short way. If we double this number and then add 1, we get 15. This explanation in a familiar language can be translated to our mathematical language, and the translated version is an equation. It has an equal sign, which sort of acts as the verb. It has the information of doubling the number and then adding 1 and resulting in an equivalent answer of 15. But the mathematical equation isn't strange or different or new or extra or anything. It is simply a translation of what I could say in English. And as soon as I start thinking about this in terms of a translation between languages, then it becomes less foreign, less alien, less strange. And I could translate this English couple of sentences into any other language. This mathematical one is no different. It's just a translation. So an equation is information. It captures information, clues, to help me figure out what this variable is. And now in this mathematical sentence, in this mathematical language, I have grammar rules and ways to rewrite these sentences and simplify them. One is I can subtract the same amount on both sides of the equation, and that gives me a different looking sentence, but it has the same meaning. Just like you can say something in two different ways, but it means the same. And then I can also divide both sides by a non-zero number, and I get a different looking sentence with the exact same information. And we simplify the equation, but it's really just a set of rules within this language that allows me to more clearly understand the information that might be hidden in some versions. So an equation is simply information, simply sentences. What is important is how I link these two languages. Now often, I might not have enough space. Let me make a new page here. Often we are given in English words our word problem. So I want to emphasize the steps in solving a word problem. And the nice thing is that regardless of the complexity of the problem, these steps are always sort of the template steps I can follow. Things might get more complicated, things might get simpler, but it's always these 4 steps. So first I have a word problem. First of all, I need the problem, right? That could be stated anywhere. It'll be stated in English for us. Let's just mix it up a little bit. We have a mystery number that let's call it an unknown number. Unknown number, and there's no need to make this complicated. I'm just shortening this problem. Let's say we multiply it by 3 times 3, and we add, let's just keep it simple, 1, and then we get, let's say 13. There's no need to make it complicated. The aspect of the problem and the solution steps are still the same. So there are going to be 4 steps. And I want to think about it in terms of these 4 steps. Step 1 and 2 are translation steps. I can write my equation, and you might jump to step 2 right away by saying 3 times x plus 1 is 13. But that doesn't make sense until I have a link between these, and the link is to explain or define what this variable x means in words. So we would have to say, so this is our heading for what the step is, we would have to say, let x represent the unknown number that is being referred to. Without that, the equation doesn't make sense. The information isn't clear. I have to have a link between the two. And this is going to come up again as soon as we look at applications. If you don't have that link, then your equation doesn't completely make sense. It might make sense to you because you've quickly done this step without realizing it. But it needs to be written down so the reader can understand how this mathematical sentence is a translation of the given problem. So then after we've made that link, we can set up our equation, which again is just a translation of the given information. Then after that, we are now in the mathematical language, and we can, so to speak, solve the equation by following its grammar rules and rewriting it to a simpler form. But it's not magic, it's not anything special. It's just following rules within that language to rewrite sentences to more clearly see what they're saying. Now, it seems very trivial when I do it for such a simple problem, and then people get to more complicated problems and think weird things are happening when nothing weird is happening. It is the same 4 steps. I just haven't laid this foundation to look at problem solving in the correct way. And I get an equivalent mathematical sentence, x equal to 4. But that sentence is so easy to read, I can very easily translate it back and write a concluding sentence. My original problem was in English. I decided to take this route of using the mathematical language to figure out the answer. I need to rephrase the answer back in the original language. I need to always rephrase my answer in the original language. and then say the unknown number was 4. And then I'm done. Let me just zoom out here. So now I know you are probably looking at this and thinking this is ridiculously simple. What did I sign up for? I thought we were doing calculus. But the problem is things fall apart when it gets more complicated and you didn't lay that foundation and learned how to look at this in the correct way, take the correct approach. Then I can have, if I look at it this way, I can have an immensely complicated looking equation. Nothing has changed. It's still translating information into a technical language where the simplification rules are easier to do. But it's not magic or anything. It is simply a different language with its own rules that's trying to convey information. So these 4 steps are going to come up numerous times whenever we have a word problem situation, an application, regardless of the methods, the mathematical methods we're using within step 2 and 3 maybe. The basic template of how I use this language to solve problems, that does not change. Any questions or thoughts so far? Even if you just say, yes, I'm still awake, everything's good, keep going. It's nice to have confirmation because usually in a classroom, I would see your face, see that 5 people have fallen asleep, that one is drooling, some are awake, and I can adjust accordingly. But in this case, I see no faces. So it's very important that you tell me if everything is still okay, even though I totally admit that we are starting at a very simple place. Anything you'd like to share at this time? Sharing is caring. And you want to be caring. You want to share your thoughts. Even if it's just making me feel better, saying, good job, keep going, you're doing great. That feels good. Encouragement feels good. Good job. Oh, thank you. Now I do. See, I feel better right away. That wasn't hard at all. And I feel so much better. So you can see these first lectures in many ways. You can see them as tedious wastes of your time, but it's more just easing into things as you're getting used to how this course is going to work with Discord and everything, or the course website. So we're just really giving you time to just get used to things. I don't like jumping in at the deep end. That's not the calculus we are going to do. Now, that said, eventually it might get a little bit tricky and difficult, but that doesn't have to happen on day 1. So when I now refer later on, like 2 months from now, I'm going to refer to the 4 steps of problem solving. So that was what happened today because it's important. And I can't forget the basics, even when things get more complicated. So I'm not wasting your time with anything that you don't need to carry with you when things get more complicated. There are 2 more concepts that I want to emphasize. The next one is a function. Now, there are different levels of complexity with which we can explain this. Just my disclaimer, I am taking the approach of looking at a function in the way that we need to. It's not technically complete. It's not technically entirely correct, but we don't need to get too mathy and technical and obsess about detail we're never going to have an issue with. So I want to casually think about it as simply an input being fed into some rule or calculation, and that gives me an output. If someone complains and thinks, oh no, that's not a function, I understand what a function is. We don't need the technicalities. We're never going to run into any problems, so I don't want to obsess over it. So input variable, call it no, let's not. Let's say we have a number, let's say a 3. And let's say we want to multiply that 3 by 2 and then add 1. Then we're going to get an output. Our output is going to be 7. But I can have many different inputs, and I'll get a corresponding output. So instead of specific numbers, I can use a variable. And then the rule is going to be 2 times the variable plus 1. And then maybe I'll call the output y. Now this over here is going to be our function. And sometimes we write y equals 2x plus 1 if we want to emphasize the name of the output variable. Great, sometimes. Sometimes I don't want to. I want to give the function a name, and I don't have a name for the output variable specifically. I want to emphasize the function aspect. So I'll use f for function. And then in brackets, I need to tell it what is the name of the input variable. And then what do I do in a calculation to that input variable to produce the output? These are all the same. It really depends on my focus. This one, the y equals 2x plus 1, has an equation focus. I want to focus on the two variables in relation to each other in an equation. The f of x version has a function focus. I can't spell apparently. Focus. There's no difference in the meaning. It's really just how do I want to view this? Which place do I want to emphasize? Do I want to emphasize the equation side of it, or do I want to emphasize the input-output function side of it? That doesn't change. To the point where we just swap y and f of x without even thinking about it. Technically, you can't do that without defining that they are the same, but we do it so often because these things are the same that we don't even bother, and that's okay. So once I have a rule, the rule could be much more complicated, but the idea, input, rule, output, or input, calculation, output, relating the two doesn't change. So later on, maybe towards the end of the month, this is going to come up again because I'm doing it now. When I refer to this again, making more complicated functions and rules and associations, it shouldn't be strange because you have this foundation of what the function concept is for us. If we're doing engineering calculus, actually not even engineering calculus, a higher level math, and we talk about functions, totally different game. But we don't need that, and we don't need to be distracted by that. Okay. Any thoughts on functions? Again, I will emphasize that I am not wasting your time with anything. Everything I'm saying will come up again, is important, and the way I'm saying it, it sounds arrogant, like, oh, every word I say is important, but I've refined this to the point where it's true. I don't want to waste your time with meaningless sidetracking of things you're never going to need to know. These things are going to come up again in a big way. And then I don't want to think about, oh, what is a function? Ugh. Because there are new things. The rule is where the complexity is. I don't want to think about the basics. I want to build on top of that. So if anything in these first weeks are shaky, actually week 1, then go and review. lay that foundation so that when we build on it with more complicated things, it's nice and solid. The downside to a course like this is, I'm not going off on a tangent, super important. The tricky part to a course like this is we start really slow, pre-calculus concepts. Maybe it's super familiar, and you don't have to study a lot. You don't have to do a lot of practice to keep up with what we're doing because you've done it before, it's familiar. So then you think, oh, this course is going to be a breeze, super easy, barely an inconvenience. But then suddenly we start with limits, with derivatives, and those are all new. And then you need to ramp up your studying and your practice to go with that newness of it, or it's going to leave you behind because it's not familiar anymore and it's not easy anymore. So you need to scale your studying and your reviewing and your practice according to what the material needs. It's not the same throughout the course. We start with familiar things, which might require less work, less time from you. But when things ramp up and things get new, you need to scale accordingly, or things get out of hand very quickly. And everything builds on, every section almost builds on a previous section every time. And if an earlier section, an earlier concept is shaky, then slowly everything is going to be shaky and fall apart. And that's not what we want. Question. Could you define a function through English sentences that relates to your drawing? Sure. Let's say it like this. A function is just a fancy name for a rule that I don't want to be too wordy here. I want to be concise and efficient in my wording. Let's just say it like this, that tells us how to take an input number or two to calculate, let's say, corresponding output number. That's good enough, I think. But let me know if that doesn't make sense. So it's just a fancy name for a rule. I have an input number, pick 3, pick 7, pick whatever you want. That input number is going to be fed into my box. That's going to do something to it. That something is called a function. What is happening in this box to my input? Now, what happens decides what the output is going to be. A different rule, a different calculation, a different box, and of course, a different output is going to be fed out or spit out. But it's still, input comes in, something happens, we call that a function, that's applied to the input, and an output is the result. And that's really all we need to think about. We don't need to think about it in more complicated terms. In actuality, the function has some other restrictions, that there has to be a uniqueness to the output. That if I feed something in, there's only one answer that'll come with it. It's not going to have any vague output. If I feed something in, one answer will come out. If I feed in another number, maybe the same answer will come out. Maybe something else. But for the number I feed into the box, only one answer will result for that input. Okay. Yeah, please let me know, interrupt any stage if you need to. There is one more thing that we are going to need moving forward. And that is, what is an inequality? Inequality. Now, Let's think about the words, the English version of our 2x plus 1 equals 15 equation. So we thought about an unknown number or a mystery number. We times it by 2 and add 1, and we get 15. That is English information that gets translated. We of course let x represent the unknown. That's supposed to be a w. Unknown number. Technically, we have to link it with that first step. But once we've done that, because it's fairly obvious in this case, just a quick little example, we have our translated mathematical sentence, same information. With an inequality, I'm not going to know exactly what I get. I am going to, for example, times it by 2, add 1, but then I'm going to say the answer is at least 15. So I don't know exactly what I get. The answer is 15 or more. So the information that I'm getting is not very clear. My translation, of course, has to reflect that. The information has changed. My sentence in the mathematical language has to change as well. It's still going to be 2x plus 1, but now I have a greater than or equal to 15. I don't know exactly what my answer is. It's just going to be 15 or more. Don't know. It's a little less precise, which means my mystery number is not necessarily going to be a single number, but there are multiple possibilities. Luckily, I handled the simplification in a very similar way. It's not exactly the same with negative numbers, if you remember, but very similar. That I subtract 1 in this case, so I get 2x is at least 15. No, not 15. 14. And then I divide by 2 to get x greater than or equal to 7. So because the initial information in English was less precise, I now have more options for my answer, and my mystery number could be 7 or more. I have many actually. So this is my answer, x greater than or equal to 7, for my inequality. And I can represent that in a variety of ways. I can represent that as an inequality, so that's one representation. I can represent that as a number line. So let's draw a number line. And on the number line, I just want to have maybe a 6, 7, 8, 9, and of course that continues forever. And then I want to highlight which numbers are valid on this number line. Let's use a color. Why not pink? So 7 is okay. So I'm going to have a dot on 7 because it could be equal. And then everything bigger than 7 as well. Nice visual representation. Nothing wrong with that. It's the exact same thing, just different versions to illustrate the same answer. The last one is interval notation. Often, almost too much so. In math, we want to represent things in a very concise and short and compact way. Sometimes it's a little too much, to be honest, when we don't need to. Interval notation is simply that. The drawing is great, the inequality is great, but sometimes they can be a little cumbersome, and we want to have an alternative way of representing the same information. Interval notation is just that. So I'm going to go from 7. There's no upper bound, so I'm indicating that with an infinity symbol. Infinity always gets a round bracket. The 7 gets a square bracket because it's included. Included as a potential solution. So that's going to be the interval notation for the exact same thing. So let's just run through a couple of number line versions and their corresponding interval notation. Just make sure you remember this because, again, it's going to come up again. We can squeeze them in here. Let's look at some examples. I'll make a couple of number lines, and we want to write the corresponding. Actually, let's make a new page. Let's not try and squeeze anything in. I have unlimited pages. Why not? Let's make some examples. I'll do a few here. Let's make some number lines. Ah, 4 should be fine. Of course, the number lines keep going forever. That's the whole thing about a number line. Okay, so let's say here maybe 0, 1, 2, and 3. And let's number them all the same. Why not? There's no need to be too fancy. We are just trying to remember our interval notation, which, whether you remember or not, we would have done in a pre-calculus course or before. Actually, they do a lot with inequalities in pre-calculus. Almost too much. Too much for us. We don't need all that nonsense. It's not nonsense, but some things are more important than others for our immediate purposes. Let's get some pink action, and let's do that like so. Let's do this like so. Let's do, what should we do? That like so. And let's do this maybe. Just trying to cover everything that I can think of right now. Maybe like that. That covers most of it. And of course, if you are really concerned, I don't remember this at all. What is he talking about? I can't redo those courses that you would have done because we have a prerequisite requirement. Go and look. There are open source pre-calculus books, many places. Watch Khan Academy, all those things. If you need to review more than what we're doing, of course. That goes without saying, I hope. So what is the corresponding interval notation? I would ask you, but I don't know how we type. I guess we could type that. Square brackets, round brackets, infinity. Let's use inf for infinity if it ever comes up. So you have an infinity symbol too. What is the interval notation corresponding to our first example? Now the open circle there means that 1 is not included. Actually, let me do the first one. And you can get ready because I'm going to ask you the next one. First one, it goes 1 to infinity, round bracket, because it is not included. So in the interval notation, we have to distinguish between whether the number at an endpoint is included or not. Square bracket it is, round bracket it is not. So what would you say is the interval notation for number 2? This is your moment to shine. Don't be shy. We get much more out of a course like this if it's more of a discussion, and we have to be okay with making mistakes. I say wrong things all the time, just off camera, and maybe sometimes on camera. Maybe I'll do something wrong on purpose just to see if you are paying attention. So it's all good. Don't worry about it. All right, so now we have no bound on the left, and just because you're watching on YouTube doesn't mean you can't participate. So there's no excuse, but thank you for those that have. We have a negative infinity to indicate the left side, right? And an infinity is not a number, so it can't get a square bracket. It's not something I can actually include. There's no end, so that always will get a round bracket. And then on the high side, I stop at 2. that is included, so it gets a square bracket. Again, you're behind a screen. You type stuff in a text. Most of you guys have names. I don't know who you are. So there's no risk. There is no risk for saying something wrong. Saying something wrong is how we learn. I try and tell my kids that making mistakes is how you learn. So that if you never make mistakes, then I don't think you learn much ever. So really, don't worry about it. It's all good. The interaction is important. Anyway, is everyone happy with number 2? Then we'll move on to number 3. We do take the whole time. Wow, it's almost 50 minutes. Time flies when you're reviewing. So now in number 3, I don't go forever in either direction. I'm going to go 1, 2, 3, right? The question is, which bracket do I get? Left side, the low side is included. High side, 3, not included. So it's just a compact way. There's nothing, I tell people in pre-calculus, there's nothing wrong with your diagram. Diagrams are awesome. But somewhere someone has decided that that's not enough and they need this interval notation. It doesn't do anything new, extra, better, nothing. It's just another option that you have. Now the last one, we make a little bit of a jump. We have 2 sections. List those sections separately. Left section, negative infinity to 1. And infinity is never included, the 1 is. Right section starts at 3, goes to infinity. The 3 is also not included. Now, when we have multiple sections and we want to merge them and list them all, we technically have a little union symbol there. But is that a big deal for us? Not at all. As long as you have all the pieces, you want to list them with a comma, I'm going to look the other way. It's not important for us to obsess over the technically correct notation every single time. We want to get the concepts and the essence. But technically, the union symbol is the correct one. So if you remember that, great. If you just want to list them with a comma, I really am not going to obsess over that. So don't worry about it. So our answer from whatever inequality this comes from, I don't care, might come in multiple pieces. It's going to happen. It's going to happen a couple of months from now. You just list all the pieces. It's not a big deal. It's not a big deal. Are there any questions on inequalities? Again, we can do way more with this. Way more. We can spend weeks on inequalities. I don't want to. I don't need to. I'm just focusing on what we need moving forward. And these things will come up again, but not much more than this. So I'm just focusing on remembering what we absolutely need to remember. If you remember more, great. If you don't, that's also going to be okay, because we don't need to use all pre-calculus concepts all the time. Any thoughts or questions on this topic before I end the video, so I can edit it, make it pretty, put it in our playlist, and then I'll hang around if there are any administration or technical issues or questions that you have. The videos will all be backed up, or the live sessions will all be backed up on our YouTube playlist. It's named in the obvious way. Can't miss it. I have cats fighting behind me. That's always nice. That means it's time to end the video. But I'll be around in Discord if you have any other questions, so that we're still sort of learning the ropes here. What is this course going? How does this course work? What's expected of you? When is it expected? All those things. And that'll take time, so feel free to ask those questions as well. But the lecture portion will end here. Until tomorrow.
Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Thank you.